Greetings, I'm Professor Hobo, and welcome to another HOBOTECH News product review. I'm often asked by my viewers, why don't you review more DIY whole home backup power solutions? Well, when compared to the pre-built all-in-one units, the DIY solutions are going to be bigger, more expensive, and significantly more difficult to install. However, if you want to literally power your entire residential property off the grid or during a long grid down scenario, one of these big boy DIY Powerwall systems is really going to be the only way to go. With storm season peaking in the US now is the time to make sure you can keep everything running in your home when disaster strikes. Even when disaster doesn't strike with one of these systems configured properly for time of use rates, you can significantly reduce your power bill or even eliminate it entirely by adding solar panels. The system I'm going to review today is an entire home backup solution from a Pennsylvania-based company called Fortress Power. This system can pretty much do anything from powering your home totally off the grid to easily adding a battery backup power system to your existing grid tie. Yes, it can even work with a grid tie to sell back excess power to the utility company. And with the ability to pass through power from your home's entire 200 amp service panel and support for a mind-blowing 21,000 watts of solar, it makes the competition cry for mommy. This one's for the big boys, folks. But is it any good? Let's find out. HOBOTECH. This review is going to be on Fortress Power's entire home backup solution, which includes the NV12K inverter, a set of eFlex 5.4 LFP batteries inside of a rack mount enclosure they call a Dura-Rack, and a battery monitoring remote gateway called the Guardian. It took several weeks to get this monstrosity installed in my lab, and it now successfully runs my entire property, including 5 powered buildings with mini splits and 2 electric water heaters. So let's start with the most important part of the kit, the inverter. The Fortress Power NV True 12K is a 12 kilowatt whole home solar storage inverter that works as either a standalone off-grid inverter or as part of a grid tie system. Now what they mean by True 12K, it means it can output 12K from the inverter while still charging the batteries at 6 kilowatts from AC power, essentially making it an 18 kilowatt system. Now this is unlike other 12K inverters that output less than rated power while AC charging the batteries. This power can be output in either split phase 240 volts or standard residential service in the US, or a 208 volt split or 3-phase service. The NV features a massive 200 amp pass-through that enables sending your entire residential service through the inverter while providing a 50 amp backup for your entire home with a UPS switchover time under 20 milliseconds. Having a 200 amp pass-through makes for a much easier installation since the inverter can be installed inline at your main service entrance. And that's unlike a lot of other inverters that require a lot of rewiring to integrate. Outdoor installation, you say? You bet. The NV and eFlex batteries are both rated IP65 weather resistant and can be installed outdoors if needed. However, the batteries are not heated, so if you live in an area that experiences regular below freezing conditions, they should be installed either in an insulated location or heated somehow externally. The NV supports up to an incredible 21,000 watts of solar through 3 separate MPPT solar controllers that can accept from 100 to 600 volts of input. The first controller can support up to 25 amps of panels, while the second and third controllers support up to 15 amps each. This strongly suggests running panels in series, as the optimal MPP range is between 120 to 500 volts. This inverter also supports DC coupling, so if you need to feed DC power in from another source. It also supports AC coupling to another solar inverter or an external generator hookup with auto start up to 90 amps. Now this is a pretty big deal if you already have a grid tie system and want to just add this inverter battery combo onto your existing system as a battery backup. Yes, you can do that. This unit does support both off-grid and grid tie and will in fact export power to the grid on its own. It's UL 1741 SA grid interactive compliant and it supports frequency shifting. Simply put, it can change its output frequency to exactly match the grid so that it doesn't backfeed bad power to the rest of your neighbors. And if one NV12K isn't enough, it supports paralleling up to 10 of those units for a total of 120,000 watts of output, just in case you're running all kinds of crazy experiments in your secret lab. This also means that if 50 amps to back up your entire home won't cut it, you can add additional inverters at your main service entrance to gain an additional 50 amps as needed. The NV offers a color touchscreen, which is certainly a nice touch, pardon the pun. Of course, it offers a remote app that works on your Wi-Fi so that you can monitor and actually change many of the settings remotely, including PV and AC charging, and be notified remotely of any issues. Personally, I prefer the remote app as the touchscreen does require some accurate fingering to navigate the several pages of options. It does support the following built-in applications: backup, off-grid, zero export, time of use, peak shaving, net metering, smart load, microgrid, and its virtual power plant ready. It also has a built-in rapid shutdown system that can be set up with a remote activation cutoff switch for areas that require it. Now, to top off this amazing package, Fortress Power is offering an incredible 10-year warranty on this product, so you'll have peace of mind for your investment. Okay, now on to the batteries that you're going to want to pair up with this thing. Now, it does support the use of third-party lithium and even lead-acid batteries, but if you desire all the best built-in bling, you're going to want to pair the inverter with Fortress's own eFlex batteries. Now, I got the eFlex 5.4, which are 105 amp hours at 51.2 volts nominal, or 5,374 watt hours each. And they're rated at, get this, 8,000 cycles when cycled to 80% daily. So it's no wonder they too come standard with an amazing 10-year warranty. They are also IP65 rated for outdoor use. Now, I do have 4 of these batteries and their lockable carbon steel Dura-Rack enclosure case, which is also IP65 rated. It can be freestanding or pad mounted. Now, the nice thing about the rack is that it has built-in bus bars and battery cables with knockouts on 3 sides to make installation a breeze. Up to 4 of these cases can be paralleled together with 15 total eFlex batteries for up to 81 kilowatt hours of storage power. That's about 3 or 4 days for the average American home. These batteries, of course, communicate with the NV inverter to monitor charge rate, state of charge, and other features, but if that's not enough, you can add on the optional Guardian Gateway device that will let you peek into the details of every battery connected to the system from anywhere in the world. This allows you to geek out on battery temperature, charge rate, state of charge, and you can even hook a laptop up to monitor individual cell information from each battery. And one of the best parts about the Gateway is that it has a built-in firmware update feature, which makes it a breeze to flash update your batteries if needed. And if you run into a problem of any kind, tech support chat and ticket submission is built right into the Gateway app. Neato. Now you can see why I said you'll probably want to get the Fortress eFlex batteries along with the NV inverter. Now, many of you maybe have never heard of Fortress Power before. It's a company based in Langhorne, Pennsylvania, which is right outside of Trenton, New Jersey. They've been in business since 2016. And if you're concerned about doing this installation yourself, they do have certified installers, and their local stateside support team will guide you through a solution. All right, so let's move on to the installation. Now, I didn't film a lot of that because it was literally a 2-week process between mounting all these heavy pieces of equipment, rewiring half of my lab, running new conduit along and through walls, installing a new breaker box, and, well, all the time-consuming and boring minutia that goes along with an install of this caliber. It's going to be a different process for everyone anyway, so I will go over a bit of some of the pain points here in a moment. First, let's check out some early unboxing and mounting clips. Here's what the batteries look like unboxed. You get these accessories, some CAN bus cables, wall mounting brackets. You can actually mount this on the wall. One of the things we learned is that this bracket has to mount into this groove with these screws before you put it in. You need to mount it with the battery cables up, and then all the CAN bus stuff on the bottom. Installing the Fortress system, these batteries are a pain in the behind to get in. You gotta squeeze them in there with these brackets on, and try to feed these wires through. It's definitely not easy. You can see here what the Dura-Rack looked like empty and the process of installing these 108-pound batteries one by one. The inverter weighs 121 pounds, and it's something most folks are going to need some help with installing. The Dura-Rack enclosure itself empty weighs 153 pounds and does not come with wheels. So make sure you plant it down in its final resting place before you add those batteries, as the total weight is going to be almost 600 pounds. Here is what the dynamic duo looked like at the end of the day before any plumbing was added. And here is pretty much what it ended up looking like once it was all done. I did decide to add my own Victron 712 battery monitor to the negative lead of the battery, and this was for several reasons. First, I wanted a way to easily just glance at the stated charge of the entire system without having to reach up to a touchscreen and then try to squint and read it. Second, I plan to add my own home-built batteries into this unit, and I'll need a way to see the state of the charge of the entire kit. Finally, I want to be able to remote monitor without the Wi-Fi requirement, or I could add my own Wi-Fi monitoring layer. There was quite a bit of rewiring of the lab because the commissioning instructions weren't really that clear. This page in the manual shows a third-party solar inverter feeding into the NV for AC charging. Now, I tried to do this with my ECOFLOW DPU since that already was feeding clean power to my lab and to additional buildings. Long story short, after working with one of their technicians over several days, the only compatible third-party inverters are apparently ones that offer frequency shifting. Now, these are typically only grid tie units, which of course the ECOFLOW is not. I ended up needing to completely reverse the way I had the wiring set up. The NV, if you're using it with grid power through the grid hookups, needs to be fed with either real utility grid power or power from an inverter that supports frequency shifting. Otherwise, the NV is going to just freak out and not work correctly and potentially blow up your other inverter. Now, I actually got very lucky and was able to switch off the power fast enough. When the lights and everything started flickering, I heard loud buzzing noises coming from the other room. So be aware of this because none of this was mentioned in the manual. And of course, I took the Fortress Power System here into my secret laboratory. In fact, I installed it to power my entire secret laboratory, and that was in order to perform all kinds of crazy experiments on it. So now let's do some real-world testing of the Fortress Power System. First, though, I'm going to show you my 12 kilowatt bifacial array and how it's set up in 500 volt groups of 10 panels. So here is what I have set up on my property. It is just over 12,000 watts of bifacial panels, and they are all wired underground going over to the lab. I specifically got this type of setup so that I can seasonally tilt each one of these. These are bifacial panels. Now, these panels are no longer for sale in the US. They kind of went out of business during COVID, but they work just fine. So how I have these things wired up to get 500 volts is I'm doing all 10 panels into a pair of wires that go underground. All right, fast forward a few more days. I am almost done with the installation. I want to make sure that you guys understand you need to install these ferrules on the end of your cables. Now, they do tell you in the manual that you do need to put ferrules on everything. So that means your solar cables, your battery cables, your grid cables, your load cables, your generator cables, every cable should have a ferrule on it if it is a stranded wire, which in my case, everything here is stranded except for the grounds. Because if you don't use them and you put stranded wire in these connectors, it could have a bad connection and it could cause all kinds of issues from melting to fires to malfunctions. So make sure you do it. Also of note, there's nothing in the manual that tells you how to get these cables in here. If you look in these holes, there's no screws, nothing like that, and you might be wondering, how in the heck do you do this? And it's not in the manual, it doesn't describe it at all. So what you need to do is find a regular screwdriver, a thin one that will fit inside this hole in the top. So you push the screwdriver all the way into the back, and then you lever it like that. It opens that clamp, and then you just stick your wire in there with the ferrule on it. And I can't do this with one hand, but you should stick them both in there. Make sure all your wires are also cut to the same length. You want these all to be equal length. Okay, the Fortress Power System is complete. At least I hope so, because I'm about to turn it on for the first time and see if there are any issues. So give you an idea of the install, this is where the solar comes in. I'm going to run some conduit later. I'm still getting parts for that, but this will work for now. So I got 3 breakers in there. Each breaker is for one of the pole mounts that I have up on the hill. Solar comes down into this conduit, which I'm going to go ahead and extend this eventually. This is just temporary. And then I have these conduits for the battery and the shunt. You can see a little bit of wire hanging down there right now. I'll fix that later. I just want to make sure this thing works. Then I have grid and inverter power going through this conduit that goes into the next room. This does have 3 locks and it comes with keys, so you can lock it so nobody can mess with your stuff. In this case, I'm wired for 50 amps. Now, I don't have 100 amps in this building, so I don't have to really worry about exceeding 50 amps. So I have 50 amps for the grid, 50 amps for the load. Then I have the battery cables. This is the data cable that goes to the battery box below, and I'll show you that in a second. These are the 3 solar arrays coming in from that conduit. And then these are 2 sensors that have to go on the grid power. And you have to put them in a certain direction, and they have to go where the label is. So what that does, that measures the amount of grid power going through and sends that to the unit for calculations. Now, as I mentioned before, I added my own Victron shunt, which is down here in the negative cable. It comes up, and then I'm going to put this outside. Once I get this all set and done, I'm going to mount that somewhere outside of the box. Of course, this is the screen where you do all the settings, but this does come with an app that you can actually use on your phone to set it up. Then over here you have your emergency stop button, and this is your solar on and off switch, so I could switch this to on when I'm ready for the solar to come in. Down here, of course, we have a lockable battery box. I have 4 of the Fortress Power eFlex batteries. These are 5.4 kilowatt hours each times 4. They go to their own bus bar. You can see in there, this is the battery data cable that goes to the last battery. Then on the other side of that battery, I'm going to hook up this data cable, which goes to this router. And what it does, it allows you to communicate directly with the batteries from anywhere in the world. That's something I'm going to hook up later. First things first is that behind this label, there is a battery button back here, that little silver button. You can see it right there. There we go. Little silver button. I'm going to press it, and then the battery will start up and go through a startup routine, which takes 30 seconds to a minute for each battery. So I'm going to go ahead and push that button for all 4 batteries and get them online. Next step is to switch the battery on for the inverter. So this actually controls all the battery inputs coming in. You can have 2 battery banks connected as long as they're the same voltage. There we go. Click, click, click. We see voltage come on there. This actually is doing its startup procedure. Now, it's pretty bright in here. That's a little bit difficult for me to read from way down here. So like I said, I'm going to use the app to set this thing up. But it is powered on and working, so that's good. We're at 52.4 volts. So step 2 says I need to perform a firmware update using the app. And that basically means I need to go now, install the app, register, sign up, do all that stuff. Day 2, we're back with the Envy. I was trying to get a better solar test today, but monsoon season in Arizona means one thing. It means lots and lots of these. So here's our solar incidence meter today. It's about the same as yesterday, around 1150. We should be 1250 to 1300 at this elevation. What this tells me is that the sky conditions are still not prime to get maximum solar. Right now, you can see we're doing about 9,500 watts, and that is confirmed with the Victron, which is hooked up to the batteries. So here's the history for the last hour of charging. The green line is the solar, or PV. It says the peak was 11,373. It's the second number there in that group. So that's what we hit, and then you can see as the clouds come in, and the sun starts going down the horizon more, we get less and less solar. So right now the fans are running at about maximum because it is pulling 10,000 watts into the batteries. Let's see how loud that is from a meter away. So 65, 66 decibels. It's kind of loud, but you have to expect that from one of these whole home inverters. It's not going to be silent. Now, when it's running low wattage, it's pretty much silent. You don't hear anything. It's only when you're pulling these harder loads does it make noise. Okay, so I shut off 2 of the 3 solar inputs. So now I'm only pulling under 3,000 watts. And notice that the inverter is completely silent. So we're not getting any noise at all from this thing at 3,000 watts. So pretty much like an ECOFLOW, under a certain load, it is silent. And that just reeks of quality, because if you can make your product silent while pulling 3,000 watts. That's very impressive. That means it's got good heat management. It's got good smart fans. This is actually very well built, and it is silent. Like I said, it seems to be silent below 3,000 watts, which is fantastic. Before I go switch the whole house over to this system, I'm going to show you guys how I got my breaker boxes set up. So I got these two new boxes set up on the side of my house, and what this does is this box allows me to switch between grid and solar for all my 120 volt loads, and this allows me to switch all my 240 volt loads to either grid or solar. So by doing this, if my inverter can't handle all the 240 volt stuff like the water heaters and things, I can run the main house, and actually this will charge the car and everything from this box, even though that's 240 volt. I also have two electric water heaters in the house. Yes, this is broken, I'm getting it replaced, but the manual switch still works. I currently have both of them turned off so that when I run my inverter test, I can kick both of those on. They're 4,000 watts each. And then with all the other loads in the house, we should be able to hit 12,000 watts fairly easily. And one of the things I'm running is this 1.5 horsepower pool pump for my pool. So this runs on solar all the time. That does pull about 900 watts or so while it's running. So we're going to add this to the load as well. Okay, as you can see here, I have everything turned off. There's no load going out. There's no solar coming in. Batteries charged at 80%. I do have grid power shut off to make this test accurate because sometimes it'll pull a little bit from the grid. Let's go ahead and switch the house over. Okay, here's the moment of truth. I'm going to go ahead and push this out, and I need to do this quickly so that all the power in the house doesn't flicker. Ready? 3, 2, 1. Hopefully that wasn't a problem. So we need to do the same with this. This is going to be all my 240 volt loads, water heaters, washer, dryer, electric stove. Same thing here. We're going to put all the 240 volt loads on solar. 3, 2, 1. There, hopefully I did that quick enough. Now, the next thing we do is turn both water heaters back on at the same time. That's not something I'd normally do, but I want to push the inverter as hard as I can. And the funny thing is, we're only pulling 6,000 watts. That's with both water heaters on. And you have to guess that one of the water heaters hasn't kicked on. So that's not going to cut it. We're going to have to double the loads. And to do that, I'm going to go ahead and manually AC charge both of my ECOFLOW DPUs, which are 80%. I did this on purpose to give me a 6,000 watt load to work with. Now we're talking. We're pulling 8,000, and it's going to continue to climb. 9, 10, 11, 12,000 watts, 13, 14. Woo-wee! So 14,000 watts right now, and the inverter is screaming. 66, 67, about the same. Confirmation, we're running 13,200 watts. Now with losses, this is actually saying the batteries themselves are pulling 14,000. Let's see if we can push it a little harder. Let me go turn the oven on in the house. Okay, let's go ahead and turn the stove on, put it on high, let this sucker heat up, and let's go out and see what load we're pulling now. Back down to 10K. I guess the water heater shut off. Dang it. Okay, we're still at 13,500 watts. I'm gonna have to put on some more 240 volt appliances. All right, let me try one more. We're back to 14,000 watts. That's pretty crazy out of a 12,000 watt inverter. But yeah, there's things popping and clicking, relays. Yeah, it's deciding to just go ahead and put it, whoa, just shut everything down. All right, looks like we found the limit of the inverter. Let's go ahead and shut everything off and go back to doing the next test. So one of the very cool things about living up here in the Arizona mountains is in the summertime it rains a lot, and we end up getting a lot of rainbows. You can see one right there. Got just a partial rainbow. Now, of course, it goes all the way up, but you can't really see it on camera. You're only seeing that little bit. But every time it rains during the day, we get a rainbow, so it's kind of cool. So yes, we just had a pretty severe thunderstorm. So I wasn't able to finish my solar testing for today. So 2 days in a row, the best I was able to get was about 11,700 watts out of my 12,400 watt solar array. Not too bad, especially seeing that the sky conditions have not been great. Now, as for my last test, where I was pushing the inverter to 14,000 watts, and the lights started blinking and things started happening, that actually wasn't the fault of the inverter. Now, because we had to rewire the whole system to get the NV to work with the way I have this place set up, we put a little bit too much stress on one of the connections. And when I pushed that much power through, it kind of shorted out and melted. We had to cut the wires, redo the connection, and everything's fine. It really was testing the power of my lab wiring more than the power of the inverter. Unfortunately, I don't have any more time to do any more load tests, but I do know for a fact that it can pull 12,000 watts all day long I've done it for more than an hour. And the fact is, it's kind of difficult to pull 12,000 watts continuously. I can't keep my water heaters and everything running that long to pull that continuous load. So that just means that's going to have to be a good enough test in this situation. Now, this inverter can pull 18,000 watts for a short period of time. We pulled 14,500 for a couple of minutes before the wiring gave in. We have that fixed, so that's all good. So onward to the next test. Okay, say there's not enough solar. As of right now, let's pretend that there's no solar coming in, say it's nighttime, and we're still draining the battery. Now it says 92%, but let's pretend that the battery's about to die. What could you do? Now, one of the really cool features is that you can click this Start Quick Charge and it will AC charge your battery. The quick charge there runs off of grid power, so let me go ahead and turn the grid back on and then we'll go ahead and try this feature out. Okay, so when you first turn grid power on, it's actually going to pull power from the grid. It's going to sense it, make sure that the grid power is good and clean, and then it'll switch back over to running off the battery. So if you see this, instead of it running off the battery, it's not like there's something wrong. That's just the way this works. It always seems to test the grid power before it switches back to battery. So we got to give this a moment, and then we will try the Start Quick Charge. Okay, grid power is now on and the battery is discharging to the house. So let's go ahead and choose Start Quick Charge. And now it should actually switch to grid, charging the battery. Okay, so there we have it, 6,500 watts being charged from the grid while it's also powering the loads connected to the house. Now let's say that the storm's over and solar comes back out. Will it AC and solar charge simultaneously? Let's turn the solar back on and find out. And there you have it. We have just over 3,000 watts of solar coming in. We have 4,000 watts coming in from the grid for a combined charge of 6,500 watts. Now this is all happening while the home is being powered by grid. So let's go ahead and shut off the quick charge and see what happens. Okay, we shut off the quick charge, so no more power from the grid. But because we have enough solar coming in to power the loads from the house, the battery is not being charged. Now, it would charge if it was a lower state of charge, and you can set this up in the settings. But in this case, the battery is just hibernating while the solar is directly powering the loads to your house. So this works with all three ways to charge your batteries and run the home. Now, this here is the EPS. So if I shut the grid off, the arrows will go down to this, meaning it's already on backup power. Basically, it's running on UPS mode. This product, of course, will combine solar with battery and even combine with grid to power your output loads. In this case, we're pulling about 3,700 watts on the load port. We're only getting about 770 watts of solar in because it just rained, and the rest is coming from the battery. So for this review, I've decided not to go through a capacity test on these batteries because I know thanks to this Victron battery monitor that they are 105 amp hour batteries, and to fully discharge and recharge 21 kilowatt hours is a pretty big pain in the butt. Like, I would have to run a whole bunch of loads for more than a day, and then the only way I could really do that is to hook up to the house, and that means possibly having issues with power at the house. Now I'm going to drain it down to zero, and then all my appliances, refrigerators, computers, everything that people are doing gets shut off. I don't want to have to deal with that. So we're going to go ahead and bypass that in this video. Now I can tell you, since I do have this Victron shunt plugged into the negative lead, so that means any power coming in or out of these batteries is measured. It does match up with what comes on the screen. Okay, AM radio test. I have the unit shut off. Just basic static coming through. Let's go ahead and power it on. Okay. Go ahead and put the loads on. That turns the inverter on. I'm going to go ahead and close this just so we have some barrier there. Do note there is a Wi-Fi transmitter over here. All right, EMF test. I have the unit completely powered off. We got a baseline of around 4, which is fine. Let's go ahead and turn it on. Actually, not too bad. 35, it drops back down to 20. Let's go ahead and turn the inverter on. All right, now we're pretty close to the power lines. So let's move away from the power lines and close the door. Actually, very nice. I mean, it's pretty much not putting out anything at all. That is fantastic. That inverter is on and actually powering loads right now, and it's not doing anything. So This case, being metal, probably helps quite a bit. So this is very well shielded from EMF interference. Let's take a quick look at the app. You can see in this case, we're feeding power in from the grid to the NV. Solar's coming into the NV, and all that's going into the battery while also powering the loads. So right now we're in quick charge mode. We're charging from the grid. And what you need to do every once in a while is hit this refresh, and it will refresh these numbers in case they change. This next screen, so this will actually show you your state of charge of your batteries, the solar coming in, your grid consumption, your battery, all that, and you can do month, year, or total. This screen has all the important remote options. You can go into the application settings. You can change standby or normal mode. This is your generator settings. You can tell it to manually charge from the generator, when to stop and start. Your actual charge settings for the unit. This is charging from the grid. And you can also set time slots. So if you have a time of use plan for your utility company, you can tell it to AC charge when rates are cheap and then discharge the battery when they're expensive. Now, charge first PV, what this means, if you activate this, this will force the solar to charge the battery before anything else. I usually leave this off and let it make up its own mind. This also has time of use, so you can set this up to charge first at certain times of the day. Last, we have the discharge settings, which again, you can go by state of charge or voltage of the battery, depending on what kind of battery you have. The on-grid cutoff is when the inverter will stop outputting power when you're on the grid. And if you're off the grid, this number has to be lower or the same as the on-grid number. This will shut the inverter off when it's an off-grid at 5%. Now, you can change this to 0 or up to 90% on either one of these, but remember, the off-grid has to be the same or lower. You can set your discharge current. You can force the batteries to discharge. Say there's a situation where you want to force discharge the batteries even though the conditions would otherwise prevent that. You can do that here. And also, again, time of use. You can put in there at certain times of the day you want it to force discharge. And there you have it. That's everything that's available for the app. I do want to mention that you can go to this website address, take off the www, that doesn't work, and you can monitor your system from any computer in the world, including tablets and cell phones, as long as you have a web browser. And you can go in and see and change your settings through the porthole. Now, this is just a small part of what it shows. I was just messing with it myself. But this gives you an idea of all the real-time information that you can actually get through the web portal, which is really neat. So if you're a numbers geek, this is your kind of thing. Look at this. It gives you an energy summary for all the days, weeks, and months that you use the thing, and it can pretty much tell you everything you need to know. So what do I think about the Fortress Power NV inverter and the eFlex battery home backup solution? First, I do need to say that now I have the Fortress system set up properly, it is a fantastic piece of kit. Before I had it working properly, I was calling it a piece of something else pretty much every night. And the reason I had such a hard time leads me to my first dislike of the product. And that is the lack of documentation for the plethora of setup options on the screen. I mean, it's pages and pages of options, and there's not a lot at all in the manual whatsoever as to what these options do or how they interact with each other. Now, don't get me wrong here. The installation documents in general are pretty superb. I mean, they tell you exactly how to physically hook everything up. There's detailed instructions in here on how to install the batteries and the cables. This is a pretty thick document here on the batteries themselves. There's an integration guide. All of that is fantastic. And all that's actually fairly clean cut. But they don't explain how to install the PV wires, and there isn't a single YouTube video about it either. The whole thing about third-party inverter compatibility also was completely left out of the documentation. How you hook up an external generator is covered in the documents, but not what options to select in the setup screens to get the thing to work. The main gripe over and over again comes back to the lack of in-depth documentation for each feature that it has. Now you might be just saying, okay, maybe they have some videos online that you can watch, and yes, they do. But these videos literally mimic what is already in the user manual and don't really offer any new information. I watched several videos from them, hours of videos in fact, and none of my questions were answered. For example, if you check the off-grid output option, it turns on something called backup mode. But what does that do? What about if you check the microgrid option? Now the manual says you check this option if a generator is connected to the grid port, so think about that. If you have AC power coming in and you have a transfer switch where you could switch from AC grid power to a generator, you think, okay, I would use this microgrid option so it wouldn't backfeed power into my generator. But that's actually not how it works. And that sounded like that was going to be the solution to my problem with the ECOFLOW backfeed problem, right? Wrong. Now this option causes the batteries to not want to discharge as long as grid power is applied. And it causes other wonky behavior. Now each one of these things I just mentioned took several days of troubleshooting to figure out. Thankfully, their technical folks are very helpful, and in the end, everything worked out just fine. I just wasted a lot of time, and with me, time is money. I could have released other videos in the time it took me to set this thing up. Now, another thing you're definitely going to want to do is update both the inverter and the LCD firmware. The latter requires a USB flash drive that's 32 gigs or smaller, formatted in FAT32, with the files you have downloaded from their website. Now, they have changed some important features, and to have full remote access to work correctly, you do need to update both the firmware of the inverter and the LCD. Now, that being said, the NV and eFlex setup is a technical wonder. I love the thing. I've been running it for several weeks without any hitches or malfunctions, and that's really the most important part of this review. Everything I complained about ends up being a big nothing burger once the whole thing is online and working properly, and I'm very impressed with the system itself and the folks at Fortress Power. They just really need their technical writers to publish an addendum for dummies that covers in detail what every option and feature does, along with the potential conflicts, because if you check a box and it doesn't uncheck another box for you, it allows you to actually check multiple boxes that may have conflicting features. So they definitely need to be much better explained in the documentation. Otherwise, I feel the Fortress Power products are top-notch, and I think the DIY community will benefit greatly from having them available on the market. As for pricing, you probably guessed by now that the Fortress Power system is not cheap, and I mean that in the sense of both price and quality. If you only need a bare-bones off-grid system with a couple of features and batteries with a basic warranty, the market is already saturated with that. If you want something that's actually state-of-the-art with epic solar support, huge clean output, is both on and off-grid friendly, is massively scalable, and offers a full 10-year warranty, you have the Fortress Power system. Now, I'm personally one of those people that always spends more on higher quality products, because I hate doing things twice. I literally can't stand rewiring something twice. It drives me bonkers. I have a lot of pricey things plugged into my home, including an EV, and I personally wouldn't trust running my entire property 24/7 on a set of cheap inverters. This is why I decided to go with Fortress Power. So what's the damage? As of this filming, I haven't received final discount pricing for HOBOTECH viewers. So you're going to need to check out the description of this video for links and any discount codes offered, and add it all to your cart to get a final price. Be aware that the links are going to take you over to their Texas distributor, Solar Sovereign, where you can pick it up for the best price on the internet, including shipping. I'll also put a link on screen with a QR code for those watching on TV that will take you on over to their main page where you can check out everything Fortress Power has to offer. Thanks for watching. If you learned something today, don't forget to give me that thumbs up below. And if you're not a subscriber already, you know what to do. That's it for now. Till next time.
Odin commands you to like and subscribe, and clean my litter box.